Hello everyone, this is Shivam and today I'm presenting my visualization lab 2 assignment. For the assignment, I have built a simple web server based on Flask and visualize the data using D3.js in the front end. The lab is primarily divided into three tasks. In my dashboard, users can easily navigate between these tasks via the buttons in the nav bar. Now for the first task, is related to data clustering and dissemination. In this task, I have implemented two different kinds of sampling, random sampling as well as stratified sampling. Now, random sampling is implemented such that each sample has an equal probability of being chosen. For stratified sampling, the total data set is divided into separate groups called strata. In order to divide my data set into different stratas, I have used k-mean clustering technique. Now to determine the optimal value of k, I have used the elbow method. This method looks at the distortion as a function of the values of k, and one should choose the value of k such that increasing further k has minimum effect on the improvement of our distortion. Now, based on this graph, I have chosen the value of k to be 4. Now, I also allow users to scroll down and see the sample data that was collected so again, as we are looking at two different kind of samplings, the users have option for random samples. There are 100 random sample data recorded over here, and then also have the option to list the stratified sample, which is again 100. But in here, you can notice we have 25 different data belonging to specific clusters, and we have four different clusters. So we have cluster 0, 1, 2, and 3. I also allow users to refresh the data if they want. So when the refresh button is clicked, the fresh sampling of data is fetched from the backend. So now let's move to task 2. The second task is related to reducing the dimensionality of our data set. For this, we are using principal component analysis, or PCA. In order to determine the intrinsic dimensionality of data, I have plotted two different types of scree plots. The first type of scree plot plots the variance against the number of components. The second type of scree plot plots eigenvalues against the number of components. This scree plot also adds Kaiser rule criterion for easy identification of intrinsic dimensionality. As per this rule, if increasing if any number of component has eigenvalues less than 1, they are insignificant. So based on this, we can easily see that the number of components for the number of PCA component, the optimal number in our data set is 2. Finally, and also both these graphs are plotted for both kind of sampling that we have as well as the complete data set. Finally, for the task, we were also supposed to obtain the top attributes with the highest PCA loadings. This is again done for both kind of sampling as well as complete data. The top three loaded attributes are separated from the rest visually with the help of this little separation. Now in my dataset, you can see that different types of samples produce different high weight attributes. This is because of the nature of my dataset, which is a yearly record of fertility rates and therefore does not have inherently categorical attributes. Finally, moving to the task 3. The third task is related to visualizing the original and reduced data. Before exploring the visualization, let us have a quick look at the legends. As you can see, we have two different kinds of categorization. The first one is a natural category by which various countries are divided in different regions. In this visualization, this categorization is highlighted using different color. For example, pink for Africa and yellow color for country belonging to American subcontinent. Now, the second kind of categorization is the result of k-mean clustering. This is visualized by different shapes in the graph. So cluster 0 is represented by a plus sign, uh, cluster 1 by a diamond, and so on. Now let's take a look at the first kind of visualization, which is a 2D scatter plot of our top two PCA vectors. In this visualization, we can clearly see that not only are k-mean clusters, but also the categorization based on the region holds true, as the countries belonging to same region and cluster seems to be in one part of the graph, whereas countries belonging to different cluster and different region are clustered together in a different part of the graph. In here, we can see like these pink countries, which are African nations. They are in here. The left side is dominated by the European nations, which also belong to cluster 0, and in the middle we have countries belonging to cluster 2 and region Asia. Again, the visualization is done for stratified sample, random sample, as well as complete data. Moving on, the second kind of visualization is a MDS scatter plot. In here, the distances are Euclidean and correlation distance, and here too we can see both the clusters, both kind of classifications holds true, as the countries belonging to Africa and cluster 1 seems to be at the extreme right of the graph, whereas countries belonging to cluster 0 and Europe seems to be at the extreme left of the graph, and the Asian as well as American countries somewhere in the middle of the graph. Again, the visualization is done for stratified sample, random sample, as well as complete data. Finally, we plot the scatter plot matrix with three highest loaded PCA attributes. You can see that these attributes are showing a clear linear positive correlation. This makes sense as my data set is an yearly plotting of fertility rates for different countries around the world. We can also very clearly notice the difference between African nations and European nations, where the African nations tend to be at the higher end of the spectrum, and whereas the European nation tends to be at the lower end of the spectrum. We know this is true because given the years of data which we have, for these given years, African countries have reported year after year a high fertility rate compared to European countries. And again, we have Asian nations as well as South American and North American nations somewhere in the middle. This scatter plot matrix is also, as all other visualizations are done for all stratified sample, random sample, as well as complete data set. So that's all for my assignment. Hope you liked it. Thanks for watching.